Hello guys, in this tutorial we are explaining how to design and simulate a FM transmitter circuit. First of all, let me explain how the circuit works before we move to the design of the circuit and the simulation. This is this is circuit of FM transmitter, and this will be the circuit that we'll be simulating and we'll be designing. So as you can see that this terminal is labeled audio in. This way you connect your microphone if you are using a microphone, or your audio in, your audio cable that will be sending the signal or the audio that's want to be transmitting through the FM transmitter. The capacitor, as you know that the microphone has a positive and negative terminal. Connect the positive to this place and negative to this place. And if you're using an audio signal, so connect the positive to this point and negative to this point. This capacitor is called DC decoupling capacitor. It transmits the signal sent through this audio in to the transistor. And this transistor is the component that amplify or pre-amplify the signal sent through the audio in terminal. It amplifies it to a reasonable signal that can be sent through the transmitter. This R1 is the collector base bias resistor. It biases the base of the transistor, and with the help of the input signal through the audio in, the signal will be amplified. It will be amplified and sent through the connector and this capacitor to the next stage. This capacitor is called coupling capacitor. As you can see that all these capacitors are electrolytic capacitor. This is the positive terminal and this is the negative terminal. Now this resistor is the resistor that provides the connector currents for this first stage. Actually, this first stage is called pre-amplifying stage. Now this capacitor is called power supply bypass capacitor. Power supply bypass capacitor. You can see the positive terminal is connected to the positive of the input battery. Input of the input of the battery. So the positive terminal of the battery and the negative side of the capacitor of the bypass capacitor is connected to the negative terminal of the battery. Now these two resistors are called bias resistor. The bias the second transistor. So as I said earlier that the signal from the first stage, which is the preamplifying stage, will be sent or will be coupled to the next stage through this C2 capacitor, which is coupling capacitor. Now these two components are the most important components in this circuit. These two components make up the tank circuit, which is also known as LC. Tank circuit provides the oscillation that is needed for the transmission of the signal. The frequency at which this circuit will be working will be transmitting the signal depends on these two components, which is the inductor and the capacitor. Actually, this capacitor is a variable capacitor, as you can see. The formula for the calculation of the frequency that the circuit will be working with is F frequency equals to 1 over 2 pi square root of LC. Now this other capacitor is used to maximize the range of the circuit of the transmitter to maximize the range. This is the power supply, 12 volts. You can increase it, you can decrease it. This capacitor is used to couple the signal sent through the signal sent through this power tank, this through this tank circuits and the transistor to the antenna to transmit it to the receiver. Now this stage, the combination of tank circuits and this transistor is called oscillating and modulating stage. Oscillating and modulating stage. This is where the modulation occurs in the circuit. It's this way the transit. I mean, with this way the circuit plays the signal on the carrier signal. So it places the modulating signal on the carrier signal and sends it through the antenna to the receiver. Now let's move to